Hi guys, so we're going to be solving this question. This question is slightly different because the voltage output is across the capacitor, which means the calculation was slightly changed. So using KVL, you can see at this point we can go around the loop. So the loop will be this is positive, this negative, this positive, this negative. So taking KVL around the loop is going to be VIT plus RI because that's the formula for voltage across the resistor. Then it will be plus 1 over c integral I dt because this is the formula for voltage across the capacitor plus, sorry I skipped this, L di over dt. So this is simply going to be equals to 0. So this is basically mesh analysis. Now you can take the transfer function, sorry, you can take the Laplace transform of each of this. Is the Laplace table. You can see this is simply going to become, because we're going to the S domain, this will simply become this plus I, this will be actually IT. So this is what we're going to use. So A is a constant in this case, so that's R, that's representative of R, and this is representative of I of t. This will simply become R I S plus, this is the integral form. You can see 1 over c remains the same because it's a constant, and the integral become I S over S plus, for the this one is going to be from this second one here. And since we are assigning initial conditions to 0, we can ignore this part. So it will become L S. X in this case is our I, so I then S. We can, this is equals to 0 by the way. Now we can simply make V in subject formula. So this supposed to be minus, not plus. So you can just take it to the other side. Now the formula for the transfer function, let's name it as g of s equals to V out over V in. So now we found our V in. But for V out is simply the voltage across the capacitor. In this case, the voltage across the capacitor, as we've already found, is this. So 1 over C I of S over S. So we can simply write out the formula now to be G of S is equals to 1 over C I of S over S all over all of this. So just like this. Now, the truth is, when we're writing transfer functions, you don't really want to be seeing negative powers of x of s. So you don't want this. So we have to try and simplify this in a way that we won't be getting that. So we can multiply through with c s over I s. Hmm. And this is not like rocket science, like over c s I s. And I'm just thinking, okay, how can I cancel all of this out? You can simply, make this numerator, make this denominator, and then it cancels out. So this is going to leave you with 1 at the numerator. Multiply the same thing on the denominator, and you're going to get LCS squared plus RCS plus 1. So this is simply your final answer. Thank you for listening. Hope you understood.